To introduce Dan Bowen from Microsoft.
Is this the clicker? Yay. Hi. There we go, that's better. Hi, I'm Dan at Microsoft, and you got me just before you go to lunch. I'm what's called a technology strategist at Microsoft, so that means it's my job to kind of think outside the box with people over the next 3 years. So think about the future, think about innovation, and really trying to change the kind of current processes that people are doing, right? Now, when we think about innovation, you've listened to lots of speakers today, right, and they've been great. But when you're thinking about innovation, it's all about creating stuff and your own IP, your own intellectual property, right? Now, if we think about innovation, now I'm going to talk to you a bit about Xbox today, about artificial intelligence and stuff like that as well, and quantum computing, right? Now, when you're thinking about innovation, that's making something new, okay? And you've got ideas. There's people in the audience here who've got ideas that you can create today. You don't have to wait for school to teach you it, because they won't. You don't have to wait for UTS to teach you it, because they won't, right? It's too slow. Curriculum building in schools and in universities is too slow. You've got to innovate, you've got to be in charge of your own learning, you've got to look and identify career pathways for yourself early on. And an example of this is these folks here, right? That's ice farming in Canada hundreds of years ago, right? Now, they used to farm ice. They used to make ice, and they used to like put the big warehouses and like farm it out. And then to innovate, you know, to make more money and to get more impact, their innovation was to get horses to get the ice out quicker, right? So you get more ice, you get it further out, and all this kind of stuff. Great. It is innovative, but it's incremental. It's not really innovation. What innovation is when you make the refrigerator, right? And then people make it for themselves. Okay, so that's what you've got to think about when you're listening to people today. It's think about how you can take the ideas that people are talking to you about, and how you can make something and innovate and solve problems. Now, these are the trends that I'm seeing in industry at the minute. You've had people talk to you about cybersecurity today, or you will have later on as well. Cloud is really, really big. So data centers and cloud technologies and things like that. And also I've put on here quantum computing, because people are thinking about that quite a lot as well at the minute, because that's something that's new. So they are kind of three mega trends, as it were, right, that are kind of being developed at the minute and worth thinking about when you're thinking about careers and things to learn, right? So what's happening now? I'll give you some examples here, projects that are happening now with some of the Microsoft Azure technology. Azure is our cloud, right? There's 3 players in the world doing cloud. At a large scale, so that's going to be Microsoft. Amazon Web Services are doing cloud, and you've got Google doing cloud as well, right? There's some other little players on the fringe and things like that, but this is where everything's happening, where artificial intelligence is happening, where facial recognition is happening, things like that. So these are some examples of real things, right? This one at the top left here, this is just a screenshot here, it's not a video it's going to play, but we've got, we use AI to identify fish in Darwin Harbour. Ooh, Dan, really? That's exciting. Yeah, it is actually. Because you can't get in the water in Darwin. Do you know why? Crocodiles will eat you, yeah? They're very hungry. Well done, good answer, love it. Yeah, exactly. They'll eat you. So you don't want to be getting in the water with them. Well, you could, yeah? You won't be getting out of the water, that's the problem. So we've got drones that go underwater to take video footage and count fish stocks. So it's facial recognition for fish. Yeah? He goes, hey, there we go. There's a cod or whatever. Really important, though, because fish stocks are dwindling up there. On the right-hand side here, we've got magpie geese. We've got drones that fly over Kakadu, which actually allow you to actually identify the kind of indigenous bird population up there, and also some of the species of grasslands up there to preserve that, because the grasslands are also diminishing, which means that the bird life diminishes, right? So it's about conservation. Now, Microsoft make the technology to do that, but it's the Kakadu rangers and the people up in Darwin Harbour that go, I could use that to do this, yeah? And it's people like yourselves that could turn around and go, I could create something to solve a problem, right? Which you care about. You might have friends, family, areas of the environment you care about, whatever it is, you think about those and you apply our technology to it. Think about, I suppose, Microsoft and some of the other players as a platform product, right? We'd make the stage, I suppose, the platform, like we do for Xbox. We'll make Xbox, and then people make millions and billions of dollars by creating games on top of that platform. Same as these things, right? So you can actually solve these problems yourselves. Teaming up for turtles is another one. So feral pigs are eating all the turtles up in Cape York, going out onto the Barrier Reef and things. They're digging all the eggs up in the sand. So actually, we've got drone technology that goes over and checks for feral pigs, and then can identify where they are, and then we can actually protect the turtles up there. New South Wales Police and WA Police are using some of our tech as well. Now, artificial intelligence is used here. Imagine you're a criminal, right? Just imagine for a minute. I'm sure nobody is in the room, but if you are, you don't have to think too much. But criminals, right? Like, they've got a lot of digital footprints now, okay? If you go in to actually start to think about catching criminals, you've got to correlate a lot of data together. So if you think about it, when you're catching a criminal, the police used to have to just go, they'd grab somebody from the street or whatever, or they think it's a criminal, they'd interview them, and they'd work out where they were and get alibis and stuff from their friends and family, right? Whereas now you've got to work out, what about GPS? What about their mobile phone? What about their WhatsApp messages? What about their Facebook Messenger messages? What about any encrypted traffic that's going through their phone? What about their what about their laptop? What about anything, really? Anything digital? What about their smartwatch? That can give people away as well. So we've got a system that correlates all of that for the police, because it takes a long, long time to correlate so many signals together to catch all the baddies. And then on the good side of it, we're using, not that NRL is a proper sport, rugby union is, however, NRL, right, we digitize in, sorry for all the NRL fans in the room, it's not bad, but NRL, we digitize in a lot of the content, so people can watch games back, get statistics and things like that, look back historically at things, and use AI to be able to then, search for specific moments or specific people's moves or whatever it might be. New South Wales pathology, we're also going with Vic pathology. We've done a lot around the COVID vaccine and the like. There's a lot of things that you need compute to do. So Azure and cloud computing to support patient care, to support vaccine rollouts, to support actually looking for vaccination cures in the future as well, and genomics, which is what universities do. They do a lot of genomics research, which is taking apart the gene and the genome and trying to identify things to create new drugs, right? So, you can do a lot of that with AI as well. NBA, I put this slide up because my son loves basketball, but we're doing a lot with the NBA live streams, where you can actually use Azure and our cloud technology to actually identify, shot angle, speed, and all of that, to make it interesting in the actual live stream. We've also got a HoloLens and virtual reality stuff that we can kind of connect together into that experience as well. Space cows is my last example here. We've got drones. Adelaide, actually, in Australia, is the central hub to space technology in this country. So we've got a lot of space work going on in Adelaide at the minute. And Space Cows is a project that we've got, which is putting elements in space, which is drone technology, cameras on, which can actually then identify cattle movements in the Northern Territory, because they're destroying a lot of the land, a bit like the issues that we've got in Kakadu with some of the other projects I talked about earlier. So this is the cloud, right? I put the little Minecraft dude in. I used to be in charge of Minecraft in Australia. That was good fun. Minecraft Spider, this is the cloud, yeah? So the cloud is our data centers. So it means that people like your schools or universities don't need their own cloud technology, their own hardware in little buildings, or big buildings if you're a university, to run all your infrastructure. You run it in Microsoft Azure. So lots of your schools, over the next year or so, or they might be doing it already if they're forward thinking, and moving their stuff on-prem into the cloud, right? Because that saves money. It also supports the environment, because we are carbon neutral, and we can then put all of that kind of support in around our technology so people start to move to the cloud and supports your environmental stance, right? But then you can do really cool things, right? Now, when I'm talking about innovation, this is really interesting. Think about PlayStation and Xbox and the console wars, right? Whichever way you sit on that. Think about that slide I put on the beginning with the ice, yeah? So what we're doing, and we've done already, as you probably know, if you've got Game Pass Ultimate, you can play Xbox games from our data center. What does that mean? That means you need any browser, the app, we embedded into Samsung TVs, you can play Xbox without an Xbox console, and then you won't need, as well, every 2 years to buy a new bit of hardware, because we can put the best GPU in our data centers immediately, right? You can ramp it up. You can put a quantum computer into Azure if you wanted to. So you can have the fastest machine ever. You don't need hardware. You need good bandwidth, right? So think about what that's going to do to the console wars, yeah? You know, what's going to happen with Sony at that stage, right? Where are they going to start to hedge their bets? And that's innovation, and that's what we're doing there. So Xbox is going to be like Netflix of gaming, right? So just look for things like that. That's where you jump in the curve a little bit. And you can see when you're using cloud as well. Anybody know that game? Yeah. Hey, what is it? Flight Simulator, correct. Yeah, really good game. But what that does now is when you connect it on to, you know, the Azure services, it means that you can bring real-time GPS data and satellite data and weather data into the game, right? So it's augmenting your game. Yeah, you're adding stuff there all the time, and it means that you can get real-time data and real-time weather and things like that. If there's a storm, you can literally fly into the storm if the storm's happening in your area, right? So really, really clever, and it's the use of the game. And again, that's innovating and pushing it further. So if the person at the back can click on this slide, if you can't, then it's no problem, then this should play, right? Let's have a go. Spooky music. Device skips ahead to the next slide for me. We'll go into this in a second, quantum bit, but the mixed reality element, really, really interesting. If you've got a Windows-based PC, you've got mixed reality already baked into it, right? You've got Paint 3D on there that you can draw things, import models on there. You can actually then view that in mixed reality in your room. So you've got that already built in, and that HoloLens there, that's been out for multiple years, mainly used in enterprises. Rather than consumer. We haven't targeted that to consumers, but it's a mixed reality headset, right? That's a Windows PC on your head. So, you know, a bit like an Oculus Quest, I suppose, except you can see through that and it adds stuff to the room. So like my daughter plays a game on it called Floor is Lava, turns the floor to lava, you gotta run around and jump on all your furniture and all that kind of stuff, and earn points, yeah? But it's interesting. So we're doing a lot with that in health space. Some of my accounts that I manage in Australia, like the physicians, the surgeons, the GPs, the surgeons are doing a lot with that. to medical training and things, because it's so much cheaper to do it digitally than get real dead people and chop them up. There's a lot going on in the mixed reality space, right? But when you start to converge some of these technologies together, artificial intelligence, mixed reality, you can technically walk around one of those on your head and it can kind of tell you about the environment you're in. We're doing stuff with the US military around this technology as well, where we're embedding in the heads-up displays so that you can utilize the power of Azure Cloud. And all the different tools and technologies in there with correlating that with your environment that you're in, right? So again, it's about how you use these things or not. So there's some cool things that are happening now. What's happening really future gazing forward would be around quantum computing, okay? So what that is classical computers you probably know really well, it's binary, it's either 1 or a 0, right? Or a 0 or a 1. A classical computer, electricity's flowing through or not. At a quantum level, at a really, really tiny quantum level, what physics says is things can be on and off at the same time. They can be in 2 states in superposition. And that's what's called a qubit, right? So that means the light bulb can be on and off at the same time, right? Sounds weird, but at the quantum level, that's exactly what can happen. A good thought experiment around this, if you're aware of physics and stuff, is Schrodinger's cat. It was a thought experiment by a physicist who kind of said, well, if you put a cat in a box with a vial of poison and then close the lid, if the cat knocks the poison over, the cat can die, right? Sad cat. But what the thought experiment is, when you close the lid on it, there's 2 cats in there. There's a cat that's alive and dead at the same time. And it only takes the position of either an alive or a dead cat when you open the lid up, right? So have a look at that if you're interested in quantum physics, because that's one of the basic ground building blocks to understanding that things can be in 2 states at the same time, right? And what that means is, when you come to actually solve a problem, rather than going through, if you're looking to solve a maze, for example, rather than go through each individual area of the maze one at a time, like traditional computing would, quantum computing can go to that light bulb and check every pathway at the same time, okay? So you can see the speed at which, if I can go back there, you can see that. If we had to do that manually using classical computing, you'd go around each individual thread there, whereas with quantum computing, the speeds are exponential, and therefore you can do multiple things at the same time, and therefore you can get to the solution much more quicker. It's going to have major issues for things like cybersecurity, but it's going to be really good for things like checking data for the environment, solving global warming, finding vaccines, finding new drugs, and things like that, okay? So quantum computing, really, really important. And why is it important? It's because we are scaling it up and putting it in the cloud. If you're interested in this, you can learn Q# now. We've created the programming language for it. You can download the SDK for it, and then we'll make it available to everybody in the Azure cloud. So you can spin up a quantum computer in Azure, and you'll be able to do your quantum calculations in our cloud. This is at University of Sydney, just down the road. And this is where we actually bring together all the great minds of quantum in Australia and globally, and that's where we're going to build the first quantum computer. It's called Station Q in Sydney there, okay? And then finally, there's a video to show with this to illustrate quantum in a bit more detail.
Houston, we see you. We have a go. Over.
When we talk about quantum computing, it's a completely different game.
Quantum computing will enable us to solve problems that currently take longer than the lifetime of the universe in seconds, hours, or days.
We completely reconceive the space in which we do computation.
Quantum computing is like going from crawling to going to a different planet. It's different.
It's only natural that we would want to use the world's most powerful device to combat the world's most challenging problems.
We could attack global warming.
Security.
What are the boundaries of machine learning
fighting diseases.
The possibilities of quantum computers are endless.
Microsoft has the best and the brightest working on this problem.
It's really happening. Progress is very fast. And we're building a quantum computer.
What the world wants to know is what happens when we turn the machine on.
What problems will be solvable with a computer that computes in a billion parallel universes at the same time?
So that's quantum computing. That's pretty cool, isn't it? So hopefully that's brought things together today for you, right? And I'm deadly serious about this, right? You can create something yourself. You can utilize that technology. You can look at lots of the people who are presenting to you today. They've basically made their businesses out of Microsoft technologies, right? A lot of them will implement cloud technologies based on our stuff in other companies. So people, I think, Avanade presenting here today, they're a big, massive gold partner of ours, run all of our Azure and Microsoft 365 tools and technologies and things like that. So, you know, it's about what you can do and build upon, right? You don't want to, you know, if you want to be cool, you want to kind of try to make things on those platforms that we're creating, right? You don't want to work for Microsoft, you want to do your own thing. You want to make your own kind of innovation. And how you can do that is go to some of the learning areas here, right? We've got an entire learning journey. You can go to aka.ms/certification, and you can put in your student and what you're interested in, and it'll surface you all of the different courses that are available, right? You might be interested in the environment, sustainability, Azure, security, productivity, well-being, anything like that. You can actually look through the certification, do the certs yourself. You don't need to do it through school. You can just do it yourself. And if you wanted to pay $50, you can do the actual exam and they'll proctor it in your living room, right? Which is quite bizarre because you're at your living room table and then somebody kind of appears on your screen and they kind of watches you doing the test kind of thing. It's bizarre. And they ask you they say, what's that in the corner? And you go, it's my cat. And they go, please move your cat. As if the cat's going to cheat, right? But anyway, you can proctor some of your own exams. And you can go to microsoft.com/learn and just look through and see what you're interested in, right? Whether it's quantum computing or whatever. And you're in charge of your own destiny, right? At the end of the day, you are the people who are going to be making things and solving problems of the future, right? Built on, hopefully, Microsoft products, you know, or other technologies, but you know, hopefully the Microsoft stuff from my point of view. But, you know, what you'd want to do is really try to build and get your own ideas and develop your own innovation on the top of that. Okay? So I'm going to stop there, and then I'll take time for some questions. I think we've got about 5 minutes left. Okay? Cool. I think I've got a thank you slide there as well.
Any consumer-friendly HoloLenses? I'm the first one, but I was wondering if they're ever going to be planning on making them like something a consumer would be able to afford in the future.
Yes, that's a good point. We haven't really, we're trying to focus on enterprises with HoloLens because it's quite expensive. You know, I think really we're going to focus on the 3D stuff you've got already in Windows-based laptops. So if you look at your Windows-based laptop, like I said earlier on, mixed reality is built into it. And you can plug in a 3D, like a Dell or a Lenovo headset, and you can actually run mixed reality through that and VR. So there's VR experiences built in. But it's a good question. But, you know, I'm not in the HoloLens team. We may do something. But as far as I'm seeing, it's mainly enterprise and things like the military and stuff. You can't go out and buy one and develop for it. All of the stuff online is all, you know, you can use the Holographic Academy, use Unity and develop stuff for it. But in terms of getting out to consumers, watch this space. We might tie some into Xbox at some point. Who knows? Thanks for the question, though.
All right. I have a few questions, so please bear with me.
Okay, go on. Question number 1.
All right. What happened with Windows 9?
No idea.
Great. Not even Microsoft.
Next
knows.
question. It's a marketing thing, to be honest with you. That's nothing technical about that. It's marketing people. You know, in Microsoft, it's a good point, actually, thinking about it. There's more than technical jobs in Microsoft. We've got lawyers, we've got marketing people, we've got all kinds of, you know, video editors and people like that. Marketing team deals with product names and things, so it was obviously something that they decided to do and just jumped to 10. Next question.
I'll argue with that. I'm not sure if you'll know this, but do you know why in around Windows XP they moved from NT instead of using DOS?
No idea.
Well, I guess
Sorry, I can. Well, I've got some ideas there, but we might bore everybody here. The leaps in operating systems actually do quite a lot underneath, to do with DOS, like you're saying. NT was more like networking and kind of enterprise grade, so it all got a bit confused from the development point of view, so they tried to break it all apart. But I can chat to you about that for hours after if you want. What's the next one?
What do you personally think of Windows Vista?
Didn't like it at all. Yeah, sorry. Didn't like that one. I like Windows 11 though. Cool.
Oh, and my last question.
Okay.
I know you're making ARM versions of Windows 10 and 11 because I'm part.
That's right. Yeah.
I'm part of the insider group.
Well done.
I have an M1 Mac, and
Cool.
yeah, virtualization is just a pain in the butt. How are you going to improve like running 64-bit applications and like Intel applications on that ARM processor?
There's a lot of work going into that at the minute, and it's our engineering teams. We're putting a lot of it into our cloud-based stuff as well, but on the actual processors themselves, the engineering team working hard on that. You just watch your space for that. There's stuff coming very soon, actually. So
Yeah, because there's programs like Crossover which can run 32 and 64 bits on the ARM processor.
I know. There's a lot there, but it's a really good question, and I'm happy to chat to you later on about that. People at the back, quickly, wherever you're filtering in.
I didn't get a ticket.
Sorry, say again. Cloud service, it'll cost quite a lot. Cost us quite a lot of money because we've got all of those services, as you saw earlier on. So there's a lot of those services that we've got to run there. It depends on the regions and where in the world they are, but it's in the region of millions. But then that saves people locally. Globally, we'd be spending billions of dollars on our cloud infrastructure. We also got to spend money on renewable energy as well, so that we can use water power and hydropower and air and all kinds of things like that to support the air conditioning units. And there's a whole heap of stuff we're doing. So we're trying to save costs on that, but it does cost a lot of money to run that, but saves money for consumers. Question? Can you take a microphone, because I can't hear it that far back up? Who's got the mic? Oh. Yeah, go on. And I'm going to reverse through all my slides here so that people can see where we are.
So,
Next
sir,
question? Yeah.
quick question. How can Microsoft help in the field of biomechanical and biomedical engineering, in specific prosthetics?
Oh, we've done quite a lot in that area. We've done work around the technology around the Internet of Things. So worked with the Raspberry Pi Foundation, obviously microbits as well, but done a lot on the IoT side to it. So we've done a lot of the kernels and the coding for IoT, and we've got a lot of that embedded in Azure as well. So we've done a heap around that. That's a great question.
Here you go, sir.
Any more while people are still filtering in? Yeah, go on, shout it out. Oh, go on.
Thanks. Oh. I was just wondering if you see any applications of quantum computing to machine learning, neural networks, and intelligent AI.
Yeah, absolutely. That's exactly where most of my work is at the minute. So it's there. That's happening now. Quantum will push the boundaries of the machine learning and everything as well. Even further because they're going to do stuff quicker. But that's on the money. That question. That's exactly where jobs are in the future, and it's there now. So you can have a go of it.
Do you think general intelligence like GPT-3 then could be run off quantum computing and would run that a lot better?
Yeah.
Right, yeah.
Absolutely. Yeah.
Are you working with OpenAI actually on that? Or?
We are. We are in the founding partners of OpenAI, yeah.
Yeah, right. That's really cool.
Yeah, it's very cool. Yeah. Great question. I think these guys have got to get food now, or I think, you guys might have to go and get food now. But if you want to stay and ask some questions later, feel free to. But I think you guys need to eat food, or you're going to be starving. Thank you, everybody. No problem.